Hi everyone, it's Sal here from AIXCL. Welcome to the second video in this series of exploring the AIXCL platform. In the first video, we dived into the contents of the Git repository and we had a look at how everything hangs together in the project. The configuration files, how the repository was structured. We're going to touch a little bit upon that later on, but for today's video, I just wanted to dive in and show you what you would do, how you would progress with the command line interface, and also introduce you to some of the web user interfaces that we use for various aspects of the platform. So assuming that you've already downloaded or cloned the Git repository, the first thing you're going to want to do is simply to execute the command to orient yourself with the options and the parameters that are available to you. As you can see, we have options and parameters for being able to control the various services. This is all running in Docker, and this is essentially a wrapper for the underlying components. They're all open source components, as I mentioned previously, and that's the way we like to try and keep things. So yes, you'll be able to start and stop the stack. You'll also be able to start and stop individual components in the stack, and you will also be able to glean logs from those components to make sure everything is operating as intended. We also touched on the previous video about the profiles. I'm not going to go in there. Suffice to say that basically I'm going to be running with the system-oriented profile, which installs the full stack. This is the kind of profile that you want to use if you're going to be deploying this in a server installation and having multiple users connect to it. Otherwise, you can use one of the other profiles depending on whether you're using it or you're a developer or ops guy. Okay, the command line interface will also allow us to add and remove models. We also have some configuration options for the console. That is the multi-modal configuration, which allows you to query multiple models and be able to get hopefully the best answer back. This feature is experimental. It's been fun to develop, but yeah, your mileage will vary depending on the system resources that you have available to you, specifically the VRAM and how many of these models that you can actually load into your memory for inference. Finally, we have some utilities which we use to check the environments once we've cloned the repository, and I'm going to take you through that now. So the first thing you did was you've oriented yourself with the command line. Second thing we're going to do is going to check our environment, and we do that via the utils check env. In this system, as you can see, I'm running Windows subsystem for Linux. I like making life hard for myself. The problem with running it with WSL is that not all of the detection is working we get effectively. Now, it does work in WSL, but as you can see here, it's telling me my GPU is not detected. That is not the case. There is a GPU on this box, and I will show you how we can confirm that later. But that's typically what you want to do next, is just check your environment. Once you've checked your environment, we're going to start up the stack. Now, I already have the stack running, I believe, so I'm just going to do a status on that stack to confirm it. Yeah, so those are all up and running in my in this configuration, on this deployment. So that's great. You can start, stop, and restart those, and perhaps might be a good idea just to double check the logs. Now we can do that and across all of the components on the command line, and this will give you like a live update of every log change that's happening, and it will tell you the component obviously here. If you want to be more granular, you can simply do stack logs, and if you tab twice, oh yeah, I forgot to mention that, but if you tab twice, you will see the various components. So let's just take Olama, for example. Bang, we've got the log there. Now, you do actually, if you have bash, you do actually want to install the bash completion. That's again underneath utils. Let's have a look. It should be on the bash completion. You would just execute that, and you probably have to restart your terminal for those changes to come into effect. I should have mentioned that before. Okay, so that's the basics of the platform. But now the next thing you want to do is add your models. So let's just dive in there. AIXCL models. And if we tab complete, you have options for adding them, listing them, and removing them. Let's list the models that exist on the system that I've already put in place. These take a long time to download. As you can see, some of them are pretty big. So I've gone ahead and for the purpose of this demo, I've downloaded them, put them all into place. If you wanted to add a model, you would simply do models, add, and then where do we find our models? We find them on Llama. So let's have a quick look. You would go to Llama, you would have searching inside the library, find the model that you like, that you want to try out. Again, be wary of the sizes of these models and how they will how they would run on your system given the amount of VRAM you have. But you would simply just copy this. You would come back in here and just add that model, and it would go off and add it. I'm not going to do it now because I think I've got a whole bunch of them and it takes time to download them. But essentially what you have here is control scripts for managing the Docker services. You have a logging facility inside the terminal, and you have the ability to add and remove models via the command line. Great. Okay, so let's move along next. Once all these services are up and running, and remember we used the stack status to be able to confirm the situation there. Next thing you want to do is have a look at the web user interfaces for the 3 different components that comprise, if you like, the system user profile. And what we have there is, this is Open Web UI. This is the interface, web user interface for Llama. You can access some server configuration options here. I'm not going to go into these now, but suffice to say that they do exist, and you can moderate them here, edit them here, which is good, modify them. You can add models, and as you saw previously, we had all the models which I listed are also available via the web user interface. I've done a couple of basic inferences to check everything is working. This can be quite slow depending on the model that you're using, and again, your system resources. You're going to hear me say that quite a lot. I'm going to keep coming back to the fact that your mileage is going to vary. So apologies for that up front, but it really does depend on how much VRAM you have. Let's give it a quick test. Hello. I mean, I think I've done that before, but let's go. Hello. Let's see. And now when the model first loads up, that does take time, but once it's actually loaded into memory, it does speed up a bit. And obviously the smaller the footprint, the less RAM it uses. So in theory, the faster it goes. But that's not the only thing that controls the model's response time. And it's a subject for another video. Anyway, so while that's going off, and there you go. So we have like essentially a ChatGPT like experience through a web interface. Very nice. Now, we persist these chats. So how does that look? Well, if we go inside PG admin, localhost 5050, we log in. Again, it's admin, that example of admin. All of the credentials are inside the .env file. You probably want to put that somewhere secure in some kind of password manager or secrets manager. But for now, and for the purposes of this demo, let's just roll and see what that looks like. We have 3 databases, one for the Continue plugin, which also has a chat bot that I will show you later. And we also have the chat interface here for Open Web UI. And to just confirm that we are persisting those conversations, you can see here, there's my 3 conversations. And just to confirm, there's my 3 conversations. So we're persisting those prompts, and we can use that for later processing for whatever we want. Maybe we want to refine those prompts later, or perhaps capture them and use them for a skill. I'll go into that stuff later on. So that's the 2 of the web user interfaces. The final web user interface is Grafana. Now, if you're deploying this as a server, this is going to be really useful for you, because basically it's going to give you some information, observability about how the system is performing and whether or not you're going to need more RAM, which at today's prices is astronomical. So hopefully you don't. But yes, so let's have a quick look at this. We have dashboards for like container logs. Now you saw that we were able to glean the logs from the command line interface. This just gives us a very nice GUI that we can also use. And again, you can also do it by component, or you can do it by all. Let's do all of it. There you go. So now you've got everything, and it's running in real time. You also have some nice metrics regarding the logging, depending on what you want to do in your use case. Other dashboards that I use is the system overview, which is really nice. Gives you an idea of what's actually happening under the hood. And finally, the problem that was exhibited inside the GPU. Well, as you can see, I do have GPU and it's looking alive. And if you were here, you'll hear my laptop taking off with all of the stress that it's under. The fans are all whirring. But yes, so you do have some observability here. You also have some alerting. I haven't configured any contact points, but you can see active notifications. They're getting fired. And again, this is something that we have to go back and probably fix. So it's 100% probably down to system resources. Okay, so those are the three main web user interfaces. There are other ones, other endpoints, but for the purpose of this demo, that's probably all you're going to need to interact with for now. Now, let's jump into the actual integration with the IDE, because that's where the magic happens. I'm using Cursor, which is a fork of VS Code, and we use the Continue plugin to be able to integrate the IDE with the backend Ollama LLMs and inference engines. Cursor also has public GPT access, and there's a whole bunch of LLMs here as well. I'm not doing an ad for them because they don't pay me, but there, I'm using Cursor with the Continue plugin in order to be able to do private and secure inference here and public inference here. I spend most of my time in here, but there are times I have to be in here because the information that I'm working is proprietary. It needs to be secure and it cannot leave the building. It can't do an Elvis. It has to stay where it is. So that's what I'm using this for. And again, this is there is a configuration file for this, which we ship, but it will depend on the models that you have. So while we have a configuration, let me just give you a quick. This is what our configuration looks like. You can see that Ollama is automatically detecting the LLMs that are available, and it's just spitting out the LLMs that we have installed. We have configuration for the LLM Council, the multi-model or multi-model configuration. This is very much a work in progress. It's experimental feature. It's very much fun working with it, but it's not for day-to-day use. You would need a fairly serious box to be able to get any use out of it. But going back to how the workflow would typically work. So this again is our chat box here. Let's give it a quick hello. Let's see what it's up to. And as you can see, I'm actually using Pi3 Mini here as opposed to the other LLM which I was using in the web user interface. I'm doing a lot of work with experimenting on the different LLMs and trying to figure out what works best for which use case. And also we're trying to tune them as well. There are various ways that you can tune LLMs. Not for this topic of discussion today. Suffice to say that there is documentation inside the repository which will outline some of the testing methodologies that we've put into place. And there we go. So we've got some very slight, we've got some responses coming back. This is private, this is public. Now, how does that work? Let's say, for example, we wanted to get some information about this file and we wanted to compare the two outputs. So you can simply go into where your files are. If you right click, when you select files as context, they will end up in Continue. And obviously when you add them, you can add a file to existing Cursor chat or a new one. So let's just go ahead and add that over here. And actually, let's go and add this as context as well for Continue. And then let's just say, tell me about this file. And we could do the same here. And this is going to take a lot longer than this one, but it'll be fun to compare the output of the two based on the same prompt that I've given it. Okay, so while that's doing its thing, let's talk about the repository. Now, I did touch upon the structuring of the repository, but one thing that I didn't stress enough is the importance of how we're doing spec-driven development and how that is progressing and will be progressing, because essentially all of the magic um, that guides our LLMs and tells them how to operate with the code and to adhere to our internal standards, all of that magic is done inside this document tree. And this was generated with AI and reviewed by myself and the team. And basically, we had a discussion internally about how we wanted things to work. We decided we wanted a ticket first approach. And by that, it just meant that every idea or every thing that we wanted to do, every action that we wanted to take, would be captured as a ticket. Now, this would be really heavy lifting in the real world, because, like, who's got time to capture every idea as a ticket? But with the AI, it's really made this process possible. And that has some really interesting implications for the way that we're working, because it means that basically it doesn't exist if it's not a ticket. And tickets are super simple to create because AI is handling that creation agentically. And we have consistency in the way that those tickets and pull requests are created. So what does that look? Well, when I typically go into a repository, I would fire up a prompt that says, "Hey, go and orient yourself with the docs directory, and let me and summarize for me if you understand how the developer workflow goes." Now, there's more than just developer workflow here. There's architecture governance. There's all kinds of contracts in here, but really the developer workflow is what I'm interested in for the sake of my use case. And I don't want to necessarily be bothered by all this other information. Yes, it's super important that I adhere to it, but that's now the task of the AI. The AI understands the governance and compliance, and it understands how to raise tickets and the PRs and how to organize documentation and all of the stuff which would take a long time for a developer to onboard is now handled agentically via the inference engines in the back end. So what does that look like? Okay, well, let's go to our issues. And in here, you can see I've got only one issue. Okay, let's have a look at the closed issues. And you can see from the closed issues that, first of all, let's just pick one, this one. You can see we have a problem, we have the root cause, and we have a solution. This is all generated by AI, reviewed obviously by human beings. And you can see I've gone in there and I've done some bits and pieces. Here you can see I'm doing some manual assignment. Actually, now this is all taken care of. Also, the labeling is taken care of. Yes, we had to create the labels. We asked AI to suggest some as well. So now when I have an idea, or let's say I have to fix something, I would literally just inside, let's see if we can do that actually. Still doing its thing. We can do that here. Let's try and let's do a new one. Okay, so let's say create a, oh, what I'm saying is follow the developer workflow and create a ticket to update the docs for the LLM Council. Assign the ticket to me and label it appropriately. How do I spell that appropriately? Okay, so this is something that I can do in my GPT, public GPT, because it's just the creation of a ticket. There's nothing in there really going at this stage. It's going off. Let's see if we can. There we go. Da, 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 da. So you can see it's evoking GH, it's putting the labels in place, it's doing a search for component council, and there it goes. It's just gone off. It's created a new issue. So I wonder if it's actually done everything there. Oh, okay. So should have created a branch, but yeah, sometimes, yeah. No, normally it does, trust me. But yeah, so here we go. We have this. Let's go and have a look at GitHub. Oh, There you go. So it's created the new ticket. Now, typically, it's also creates a branch as well. I something that I have to prompt it to do. We're fixing this, and it's improving all the time. Trust me, bro, it works. But yeah, as you can see, it's created that ticket. It's putting some labels in place, and it's ready for me to. Uh, yeah, let's put some stuff in here that we can clean up, by the way. So just show you the mechanics of it. As you can see, the previous issues were also quite nicely done. Anyway, so that's essentially how I would use the public GPT. If I have sensitive information, as I said before, we switch over to the private one. Private one's slower, but hey, it's kind of price that you pay. And as I said, it's not if you are rolling this out as a server, there's no reason that the performance couldn't be at least comparable to what's happening on the public GPT. The main thing is that we have access to both workflows, and that's the key thing, and that this is doing some of the heavy lifting for us. Ticket first approach has worked out pretty well for us. I know it sounds encumbering to get your head around it. Oh my god, you have to start a ticket for doing anything, but to be honest, it adds a rigor to the process, which is ultimately does save you a lot of time. You can reuse the knowledge that's built up from the workflow, and you can then create further prompts and even skills that would then automate these repetitive tasks in a much more consistent manner. So, with that being said, let's call it a day for this one. Thanks again for your time, and let's hope this is actually saved. Thank you very much, and goodbye.